Fibonacci series with integral calculus. Fibonacci series with integral calculus. This is the mind-blowing discussion that we are pursuing. And now we are in multivariable case. Multivariable case means I have a series that is multivariable. I have a series that is multivariable. What is a series? What is multivariable? That we have many times we talk. Whatever people have seen Fibonacci series, whatever people have seen Fibonacci series, this is considered as single variable. Single variable means what is the Fibonacci series? If someone talks about Fibonacci series, what the Fibonacci series is? Fibonacci series is 1, 1, 2, 3, 5, 8, 13, 21. Sorry, yeah, 21, 34, 55, 89. This is Fibonacci series. If someone is writing a series in a notebook, someone is writing a series in notebook, that is 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and so on. If someone is writing on a notebook, then he will say, anyone, if I ask, what are you seeing in this series? Then anyone would reply, I am seeing only one thing is series, that is series of numbers. But actually there are two things in the series. Fibonacci series through integral calculus. The summation of Fibonacci series through integral calculus. This is a discussion that we are pursuing. So if someone asks, what are you seeing in the series? The someone will say, I am seeing numbers in the series. But there are two things there. Whatever number we are seeing, these are called dependent components. And what is hidden here is the position number, that is called independent component. That is missing. People are not able to trace it out. Okay, one is position number in the series. Position number 1, position number 2, position number 3, position number 4, and so on. And each position, what is the value of Fibonacci number? I have position value, position value. At position number 8, the Fibonacci number is 30. Position number 8, I believe Fibonacci number is 21. Position number 8, position number 7, it is 13. Position number 6, it is 8. Position number 5, it is 5. Position number 4, it is 3. Position number 2, it is 1. This is called, so actually there are two things. One is called position number and one is called value at that position number. Okay, this is typically drawn in calculus arena as x-axis and y-axis. If I take position number on x-axis, means if I take x-axis where x is 0, 1, 2, 3, 4, 5, 6, 7, 8, I say this is position number. Then what is your value? Value is y. If this is x-axis, this is function over x-axis, f in bracket x bracket close. Function over x-axis, that is y, and this is x and function over x-axis. If that is the case, then the if I say x equal to 0, 1, 2, 3, 4, against each x, I have function over x. Against each x, I have function over x. The function over x that I am saying, it is a vertical. Function over x is y or Fibonacci value at position number x. Okay, if that is function over x, x is, someone say x looks like index number. Yeah, it is same as array. Array has two things. One is index and one is value in the index. If I see the in computer science term, the memory management, then there are indexes in memory management 0, 1, 2, 3, 4. Against each indexes there is a value. Index is x-axis and value is y-axis. Fibonacci values are y value, the value that is stored in the array, and index is the x value. Both are extremely important. So now I have a Fibonacci series where how many x-axis is there? There is only one axis is there. That is the position number. How many y-axes are there? There is one y-axis. That is the Fibonacci value. Can we think about two x-axis, two independent variables, x-axis, y-axis? We were talking now y-axis as a dependent variable. Consider dependent variable is z-axis. Now there are two independent variables. One independent variable is x-axis and one independent variable is y-axis. X-axis, y-axis. They form xy plane. Now, someone will say, if that is the case, it looks like two-dimensional array in computer science. Two-dimensional array. Yeah, it looks like two-dimensional array. Whatsoever. In mathematics, it is called xy plane. If this is x-axis and this is y-axis, this plane that is formed here called xy plane. In xy plane, against x-axis, I have x equal to 0, 1, 2, 3, 4, 5, 6. In y-axis, in xy plane, in y-axis, again I have y as 0, 1, 2, 3, 4, 5, 6. This means that on the xy plane, I have set of x comma y points. Okay, these x comma y points are finite if x and y are whole number. If x and y are fractional number, then it is infinite. Infinite means infinite x and y is possible if I take any value of x, if I take any value of y. Understandable? These are called points on xy plane. Similar to on x-axis, if I take only whole number, then x equal to 1, x equal to 2, x equal to 3, x equal to 4. There are finite number of x up to n. But if I say x can be anything, fraction number also, then between 1 and 1.1 only there can be infinite number. Now same thing on xy plane, if I say the pair of x comma y point, if x and y are whole number, where x goes from 1 to m and y goes from 1 to n, then in that manner there are finite number of xy number. On xy plane, this is x-axis, this is y-axis. This is xy plane. On xy plane, I have set of x comma y point. At any x comma y point, what is the value? Understandable? Okay. Means if I take one matrix, if I take one matrix where x is row and y is column at any x comma y, what is the value that is stored there? That value is called hybrid Fibonacci number that we have to top now. So if I take on any x comma y, I can say it function over x comma y. That is the z value. Means if this is xy plane, consider this is origin. This is xy plane. This is xy plane. Considering this as origin. This is x-axis up to m, and this is y-axis up to n. Then this is a xy plane where the function over x comma y, if I take any x comma y here, function over x comma y is the vertical. This is a z value, is the vertical. If I talk in single dimension, if I talk in single dimension, then this is x-axis, then function over x is vertical. If I take two dimension, two independent variables, x and y, then function over x and y is vertical to the xy plane. Okay, what you want? I want summation of all the vertical. I mean sigma x equal to 1 to m, sigma y equal to 1 to n fxy. Function over x comma y, f in bracket x comma y bracket close. Function over x and y. Can you tell me what is your fxy? My fxy is fx into fy. Hop, hop, hop. In better way, we have decided to represent function over x, that is the Fibonacci series, as ux. U bottom right as subscript x, that is same as function over x. Fibonacci series univariable, single variable Fibonacci series is f u1, u2, u3, u4, ux, un, where ux is the Fibonacci value at position number x in the series. Okay, I have fxy, function over x comma y, fxy, and against this fxy, fx, what is your fxy? Fxy is uy into ux, where uy is a Fibonacci value at position number y. Ux is Fibonacci value at position number x in single variable Fibonacci series. Single independent variable Fibonacci. Right now we have two independent variable Fibonacci series. Independent variables are x, y. Fxy equal to uy into ux. What is uy, ux? They are the Fibonacci value at position number y, position number x. Okay. What is uy and ux in term of x? Ux or fx, that is the Fibonacci at position number x, is same as a to the power x minus in bracket minus b to the power x by square root of 5. What is your a and what is b? A is 1 plus square root of 5 by 2 to the power x. 1 plus square root of 5 by 2 is a, and square root of 5 minus 1 by 2 is b. This is the what the Fibonacci algebraic equation is. Anyone can search. We have proved it also. A to the power x on position number x, a to the power x minus, and then in bracket minus b to the power x divided by a square root of 5. Okay, this is the Fibonacci number at position number x. Okay, a to the power x minus, and in bracket minus b to the power x divided by a square root of 5, where b is square root of 5 minus 1 by 2. A is square root of 5 plus 1 by 2. Okay, if that is the case, then this is fx, this is ux. Yes. What is fxy? Fxy is uy into ux. Can you explain? Yeah, we will explain. It is same as if I take a matrix of x and y, then first row will be x will be 1 and y will go from 1 to n. So that is F11, F12, F13, F1n, F21, F22, F23, F2n, F31, F3, F32, F33, F3n, Fm1, Fm2, Fm3, Fmn. There are m into n values, n indexes are there. Okay, against each index, against F1 into 1, F11, F in bracket 1 comma 1 bracket close, F11, it is U1 into U1, Fibonacci value at position number 1, Fibonacci at position number 1, that is 1 into 1. What about F1 comma n, that is UN into U1? That will be how much it will be? F UN into 1. UN is a to the power n plus a to the power n minus, in bracket minus b to the power n by square root of 5 into 1. What about your fm comma n, the last one, that is un into um, where un is a to the power n minus, in bracket minus b to the power n by square root of 5. M is a to the power m minus, in bracket minus b to the power m by square root of 5. Okay, can you break the silence? What is minus b to the power n minus b to the power m? Depend upon m and n. If any one of them is odd number, then minus b to the power, if consider m is odd number, minus b to the power m will break as minus and b to the power m, minus minus plus. If m is even number, then it will be b to the power m, minus is outside. Means um equal to a to the power m plus b to the power m by square root of 5 if m is odd number. A to the power m minus b to the power m by square root of 5 if m is even number. M is even minus, m is odd plus. This is how it is. Okay, thank you very much. So can you please make the addition? So we are now seeing that the ux, uy, un, that is a Fibonacci value, its formula, actually algebraic formula, changes with m is odd or even. Now consider for the addition purpose. Now we want summation m equal to 1, sorry, summation x equal to 1 to m, summation y equal to 1 to n fxy. This is what we want. That is nothing but u11 plus u12 plus u13 u1n. plus u21, u22, u23, u2n plus u31, u32, u33. Make sense? u3, I'm sorry, I'll try again. u1 into u1 plus u1 into u2 plus u1 into u3 plus u1 into un. I believe it is all right. This way it is okay. Or actual equation I am trying is actually I have reversed it. Fxy equal to uy into ux. Okay. If I shift it in better way, then it will be ux into uy. Fxy equal to ux into uy. For the matrix x into x and y matrix or m into n matrix, first make it as x1 and y will go 1 to n, x2 y will go 1 to n, x3 y will go 1 to n. Last one will be xm, y will go 1 to n. Okay, that is the way it should be. There is m into n numbers. For any x comma y, it will be uy into ux or ux into uy. Okay, can you compute the summation? For that, I have to take, we have, in the past video, we have already done it. This is called, this is called conversion of discrete function into continuous function. What we want is summation of discrete function, that is uy into ux, where y and x will vary. Y will vary 1 to n, x will vary 1 to m. All permutation combination we have to add m into n item. This is your fxy. Yeah, fxy is uy into ux, where uy is a Fibonacci number at position number y. Ux is a Fibonacci number at position number x, that is fxy. This is a discrete function. What is meaning of discrete function is that this function is valid only at x and y as a whole number. If x and y are whole number, then only this is valid. Otherwise, if I say what is your fxy at x equal to 0.5, y equal to 3, then it is invalid. X and y both has to be whole number, then only it is valid. This is called discrete function. That's why I show fxy as vertical. Okay, these are vertical. Okay, if I want to use this summation, if I want to just calculate m into n summation through integral calculus, I have to find a continuous function. Continuous function in 3D will be a surface. Okay, like like oh, 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 like like this is the surface. Like this is the surface. Like this is the surface. This is one surface and it is continuous. Why it is continuous? If I take any point on x comma y, it is going to hit, that point is going to hit somewhere. Means for any fraction x and y also, there is a z value. There is a z value. There is a z value for any fraction of x also. Not required, it can be whole number only. So this is a continuous surface, we can see. It is a full continuous surface. Whereas this is a full discrete function. This is a full discrete function. Discrete means this is available only at few points, not all the points, but all the points. If I take any vertical, this surface is available. For integral calculus, we want this surface. It cannot be done on this digital surface. It needs continuous surface. If I transform this discrete function into continuous function, then I can calculate the concept through integral calculus. Okay, what is the concept behind converting this function into integral calculus into a continuous surface? Is take any point here on xy plane as x comma y. At that point, I have fxy. That is true. That is uy into ux. Now, if I talk in digital manner, that if this point is x comma y along x direction, next point is x plus 1 comma y. along y direction, next point is x comma y plus 1. Between that, there is no sampling we have done. So if I take a volume, if I take a surface area, if I take a surface area, if I take a surface here, okay, if I take a rectangular surface here, x, this is x comma y, this is x comma y plus 1, and this is x plus 1 comma y. If I take a rectangle like this and this goes up, 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 and it hits this surface, this may not be flat, or it hits this surface. If this hits the surface, what is the volume of this rectangular region? This volume is gxy. Consider this continuous function is gxy. Gxy dx dy, x to x plus 1, y equal to y plus 1, gxy dx dy. That is the volume. If I say this volume is same as what we have at this bottom left corner is x comma y. At this x comma y, I have fxy. If this fxy value is same as what volume I am seeing with the gxy from from point from point x to x plus 1 and y to y plus 1, then I can say that I have transformed fxy into gxy. Transformation has done. If I am able to find gxy in a manner that gxy volume with x to x plus 1, y to y plus 1 is same as fxy, then I have transformed this is our concept, not available in any of the book. This is transforming a continuous function in discrete function into continuous function. This way, someone can transform his problem into integral calculus, and he can get his problem solved through integral calculus. Transformation is required because integral calculus is continuous. It is continuous function. It is not discrete function. Okay, means what I'm trying to say is fxy at x equal to 1, y equal to 1 is same as integration 1 to 2, integration 1 to 2, again x is 1 to 2, y is 1 to 2, fxy dx dy, gxy dx dy. If volume of gxy with volume of gxy, that is a plane surface with limit x to x plus 1, y to y plus 1, if it is same as fxy, then I have transformed into. So if I say xy as 1 1, then fxy at 1 comma 1, that is u1 into u1, that is 1 1, should be equal to limit x equal to 1 to 2, limit y equal to 1 to 2, gxy dx dy. Fxy at 3 comma 5, that will be u5 into u3, that should be same as limit x equal to 3 to 4, y equal to 5 to 6, dxy dxy. For each x comma y, whatever fx I have, similarly I will have a sub-volume region with gxy. If they are matching, then I have so many fxy. For each fxy, I will have a sub-volume with gxy. If I add all the sub-volume, that is equivalent to adding all the fxy. This is what I want, addition of all the fxy only. Then that is the addition of all the sub-volume. If all the volume are contiguous to each other, non-overlapping, then net adding all the integration is same as making one integration from the lowest limit to highest limit. And we get the summation. Anyway, so we will find gxy for any arbitrary x comma y. For any arbitrary x comma y, fxy is uy into ux. Okay, can I break it uy into ux? And that will be equal to x plus 1, y to y plus 1, dxy dx dy. Can you break uy and ux? It depends upon y is odd or even. Then only I can break. If y is even, then it is a to the power y minus b to the power y by square root of 5. If x is also even, then a to the power x minus b to the power x by square root of 5. Means there can be 4 combinations here. X is even, then y is even or odd. X is odd, then y is even or odd. This will compute for the integration up to m item up to n item. Now m can be again even or odd, n can be again even or odd. means total 16 combination of gxy I'll get. If I say I have fxy where x is odd number, y is odd number, then uy into ux, a to the power y plus b to the power y by square root of 5 into a to the power x plus b to the power x by square root of 5. If I multiply these two items, then I get the fxy where x and y are both odd number. Accordingly, I have to find x to x plus 1, y to y plus 1. If both are odd number or even number, if I watch closely, if this is xy plane and this is x-axis, if x is only odd number we are taking, then x will be 1, 3, 5. It will jump 1, 1. It will not be 1, 2, 3, 4. Similarly, y will jump 1, 3, 5 and so on. So we can say that fxy, that is uy into ux, where y and x both are odd number, will be same as x equal to x plus 2, because x will jump 2. 1 it will skip because it is only odd number. Similarly, y will go from y to y plus 2, gxy dx. I have to find gxy in this manner. Then I will flip the y. Now y is even and x will remain as odd. In that manner, again it will go for even number also, it will skip 1. X equal to x plus 2, y equal to y plus 2. I have to find gxy again. For each combination of fxy, gxy will be different. Like that 16 gxy I have to find, because at the end I have to do computation for m and n only. That is the number of items in column and row. M and n can again be even and odd. So for each m and n, I have 4 combination in x and y. More or less 16 gxy I have to find, and I have to sum up. This is what we cover. Now we have 16 combination. We have 16 combination of gxy. We have 16 combination of gxy. Now, how many people have caliber to calculate 16 combination of gxy? Means m is odd, n is odd, m is odd, n is odd, m is even, n is even, and so on. Okay, means for each m and n combination, I have different x and y combination. For each m and n combination, I have different m and. So we have 16 gxy. This is what we talked in the previous session. Yesterday's session, this is what we talked. For 16 times, I have to find gxy. If x is odd, y is odd, then what it is? X is even, then sorry, x is odd, y is even, then what it is? For everything, uy into ux will differ. Okay, now how to find the solution? This is what we left as an assignment in the last. Okay, if I go with the generic way. Okay, there is a way, something called generic way. How I can solve this problem? To solve the problem, we'll go by something called abstract way, generic way. What is the generic formula we are drawing? If I have fxy as a uy into ux, fxy as a uy into ux, if this is fxy, uy into ux is fxy, then for that we have gx, fxy is uy into ux. Okay, if I take a generic way, not the, consider that doesn't matter it is odd or even. Consider that the Fibonacci number uy equal to a to the power x plus b to the power x, sorry, ux. That is the Fibonacci value. Consider this value is a to the power x plus b to the power x by a square root of 5. Consider this Fibonacci value is a to the power x plus b to the power x by a square root of 5. There is no plus minus. For odd and even, it works in same manner. Consider in that manner. If that is the case, the net calculation what we are getting, there will be only one gxy. Gxy are coming 16 in number, because m and n can be odd or even, x and y can be odd or even. If there is no difference in odd or even in Fibonacci series, then for ux or fx formula is a to the power x plus b to the power x by square root of 5. And it is same for odd or even. In that manner, we have a generic formula to find only one gxy, that is x to x plus 1, y to y plus 1, gxy. dx dy, and that is same as fxy, uy into ux. Now how to solve this problem? This is a very big thing. This is the intricacy, someone very miniature way. Someone has to understand the integral calculus, very miniature way. Let's try one. Okay, let's have a addition of first row. If I'm talking about a matrix, let's have addition of the first row. In first row, x is 1 and y will go 1 to n. Next row addition, it is 2 and y will go 1 to n. Let's make x fixed and make y variable. This is what is the integration is. X equal to x plus 1, y equal to y plus 1, gxy dy. First calculate the internal integration and then calculate the external integration with dx. If I calculate internal integration with dy, y to y plus 1, internal integration with dy, that is nothing but for a fixed x. What is the addition of full row? For fixed x, what is the addition of the full row? Okay, if that is the case, then what? Then how much it will be? I believe it is understandable. I have two integration. One is x to x plus 1. One is y to y plus 1. Gxy dy. First internal integration I'll do and then external. Internal integration I have to do. If I do, then it will be for any particular x. In gxy, x is constant and y is variable. It is same as I take any x throw, and in that I add y from 1 to n. This is same as sigma summation y equal to 1 to n 1 to n fx comma y, or uy into ux. That is, x is fixed constant, uy is variable. Or I can say last row is m, then uy into sigma y equal to 1 to n uy into uy into um is constant, only uy is varying. If I want to calculate in that manner, then I can take it outside, then I have to find gxy in that manner. What is your fxy? Fxy is uy into where m is constant. I have to find gmy where m is constant. Fxy means m comma y where m is constant, or fxy is uy into ux where ux is constant. If ux is constant, then this side I have to find gxy where x is constant, only y is variable. If that is the case, then there will be single integration, y to y plus 1 gxy dy. I have to find gxy in that manner. Okay, this is what we have as internal integration, y equal to y plus 1 gxy dy. Then someone will hint, you have to know the addition. Yeah, we know the addition. If summation sigma y equal to 1 to n f m comma y or f x comma y, if I have to add, I know the addition. What the addition is? That is u x u y, where x is constant and y will vary. Yeah, understand? U that will be u1 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 u2 u1 u3. I'm sorry, ux u1 ux u2 ux u3 ux un. This is what you are trying to sum. Ux is constant everywhere. Ux I can take outside, and inside it will come as summation of uy. What is summation of uy up to n series? Means this is nothing but a single dimensional Fibonacci summation. u1, u2, u3, u4 up to un. How much it is? That is un plus 2 minus 2. I think so. This is what I remember. The Fibonacci series summation for the n number is un plus 2 minus 2. This is what I think. So I'll try. What if n is 5, then u7 minus 2. u7 is 13. Minus 2 will come as 11. u6 is 8. u7 is 13. Minus 2 will come as 11. Is it what? 11 is the answer. 5 plus 3 is 8. 5 plus 3 is 8. 8 plus 2 is 10 plus 2. No, looks like it is un plus 2 minus 1. That is the answer. Un plus 2 minus 1. We'll try again. Let's make n add 6. Then u8 minus 1. U7 is 13, U8 is 21. So summation should come at 20. We'll try. N we have taken as 6. So 6 means I have whatever I added 1 plus 1 plus 2, that comes as 4, 3, 7, 5, 12. 12 plus 8, 20. Yeah. So this is the formula. If I want to add n number of Fibonacci series, the summation will be un plus 2 minus 1. This proves that if I am making integration y equal to y plus 1, gx comma y dy, where x is constant, that will be ux into, in bracket, un plus 2 minus 1. This is priceless. This is how someone can crack integral calculus. Now then what is your new integration? Now new integration is x equal to x. I'm sorry. Hope. I'll try again. Okay. Consider hope one step further is required. Now we have to find. We'll try again. What we are trying to find? We are trying to find gxy. When we are trying to find gxy, our concept is fxy should be equal to fxy at x equal to x, y equal to y. That is uy into ux should be same as x equal to x plus 2, y equal to y to y plus, sorry, x equal to x plus 1, y equal to y plus 1, gxy dx dy. I have to find gxy. Consider I know gxy. Consider I know gxy. If I know gxy, then the final summation x equal to 1 to m, y equal to 1 to n, gxy. The final summation x equal to 1 to m, summation y equal to 1 to n, gxy. This final fxy. Sigma x equal to 1 to n, sigma y equal to 1 to m, gxy. Sorry, fxy. This full summation sigma x equal to 1 to m, sigma y equal to 1 to n, gxy, fxy. This full summation if I take when I know gxy, and gxy is only 1. It does not differ with x is odd or even. There is only 1. So with fxy equal to x plus 1, y equal to y plus 1, y equal to y plus 1, gxy dx dy, I have found gxy. Consider in that manner. I have found gxy. Then tell me what will be the final summation. Final summation will be x equal to 1 to m plus 1, because last sub-volume on the xy plane will be, please watch our previous day video. So last volume in xy plane will be m to m plus 1, n to n plus 1, x to x plus 1, x equal to 1 to m plus 1, y equal to 1 to n plus 1. Makes sense? Gxy dy dx. Now internal integration is y equal to 1 to n plus 1, gxy dy, where x is constant. If it is x is constant, then gxy, this is same as if I try to find a summation where sigma y equal to 1 to n fxy, where x is constant. If that is the case, it will result into ux into uy, where x is constant, y is variable. Ux u1 plus ux u2 plus ux u3 up to ux un. Ux I can take it out. U1 plus U2 plus U3 plus UN. It is plain single variable Fibonacci series up to n addition. And that is same as UN plus 2 minus 1. So we will replace the internal integration y equal to 1 to n plus 1 gxy dy as a single dimensional addition. That will result will come as ux in bracket un plus 2 minus 1. Outside weighting is dx, x is 1 to m plus 1. Now in this addition, un plus 2 minus 1 will become constant and it will come outside. And it will become x equal to 1 to n, x equal to 1 to m plus 1, m plus 1. Ux dx, that is same as addition of a single dimensional Fibonacci series. That will come as um plus 2 minus 1. Net answer is um plus 2 minus 1 bracket un plus 2 minus 1. That's it. Okay, I believe it is long time it has happened. We will verify this result with the actual result, and then we will take another. Someone can take it as an assignment. What about if fxy equal to ux plus uy? We took as ux into uy or uy into ux. What if fxy equal to ux plus uy? Can someone compute it? Okay, with a similar concept. So that we will see and we will corroborate it. We will verify if the result is actually correct or not. Um plus 2 minus 1 bracket close, un plus 2 minus 1 bracket close. Please don't mind supporting us. +91 is the India country code 9483160610 the telephone number. Please do not mind supporting us or mind supporting us. +91 is the India country code 9483160610 the telephone.